One of the great challenges you have is that we have come to a new period where competing has to be done at a velocity that we've never imagined, with amounts of data that are almost incalculable. Industry 4.0 is really data-driven manufacturing, but it's much, much more than that. Here we have companies, for instance, that generate tremendously sophisticated work, building, for instance, airframes or parts of the airframes for 787s. But this process involves everything going all the way back to the original supplier and all the way out to the end of life of the product. Imagine for a minute if you didn't take care of that entire value chain. Or even better, imagine if you could monetize your knowledge of that value chain literally from the first component manufacturer out to end of life. Having that ecosystem as part of what you drive is an incredibly valuable asset that is uniquely possible because of the advancements that I've seen here in the UAE. We basically also have the opportunity, because of the tremendous interest here. 2 days ago, I was actually in Dubai kicking off the AI Center of Competence. There is really almost no effort like that anywhere in the world. I mean, it's really a leading effort to learn about how we use machine learning, how we use artificial intelligence to drive the optimization of this entire end-to-end process, again, from the first component builder to the end product, to get the balance of quality, throughput, and cost. You could always build something that lasts forever, but A, nobody would need it in that period of time, and the cost would kill you. So there's a tremendous balance that has to be done here. The other thing is, as I said earlier, the velocity of business today is remarkable, so you have to have the ability to run quickly through the learning cycles as you do development. You have accelerators here to do work on new products. You have new software elements being developed. But using cognitive capabilities, self-learning capabilities to train people, it's kind of an interesting thought. You're really talking about human plus computer. It isn't either or. It is true robotics have a disruptive element because they replace people in simple mechanical tasks. But when you're talking about the ultra-sophisticated things that need to be done here, this is where actually it's human plus AI that get you the best result. At the end of the day, you also have the ability to do something that sounds like science fiction, which is change the future, knowingly. You know, this sounds like something out of a novel, but it's not. Remember, the idea of predictive, the idea of understanding a system to such an extent you can predict the future, means you also have the opportunity to change the future. And that can have a fantastic financial impact that most people tend to ignore. Now, this all begins with data, tremendous sums of it, and it's a question of how much, and I don't think we really have a good sense of it, and this is kind of a funny example. We did some work with an offshore company, Statoil, which I'll describe a bit later. There are 80,000 sensors present in one of these offshore systems. The offshore wells generate about 15 petabytes of data. That's 15 followed by 15 zeros. They generate that much data, and it isn't used. It wasn't used. And that has a profound impact if you have that much data, but you haven't done it. The other thing is, why would you focus on a whole ecosystem instead of just that one component? It's fairly trivial. If you have 40 offshore oil wells, and they're all producing, but the ones closer to shore have elements that if you shut them down, they can no longer ship oil back to shore, you better make sure you understand your whole ecosystem, or in doing the 90,000 man-hour upgrade of one actual element, you may shut down the production for 3 others in the distance and drive the cost up by factors, not percentages. Now, monetizing that end-to-end dark data really has profound financial implications. And a lot of people talk in theory, but I love the quote from Sheikh Mohammed bin Rashid Al Maktoum. He basically understands you have to do it. Talking about it is great. Doing it is way better. Because when you do it, you learn what the real numbers are, and you're no longer waving your hands and say, wow, I've got a great idea. So we did this years ago with Statoil. And it was actually either incredibly good news or incredibly bad news. Depends how you look at it. We took their end-to-end operation and we said, look, we're going to take one of these platforms, take all the data, And we'll do predictive analytics on when we should basically change some of the hyper-expensive pumps at the ocean floor, what sequence of maintenance we should be doing back and forth between different wells that are on the same feed systems. We looked at all of this, and we basically went and said, yep, we're all set. We're now going to start running under this new regime that we've designed jointly with them. After we couldn't agree between us because we all have a bias. We all wanted to declare this a success, but we figured let's bring in an independent third party to assess the financial impact. So we did. We brought in the Oil Industry Association of Norway. It's called OLF. And we sat down with them after about 9 months, so they had enough time to really figure out what the financial impact was. And what was absolutely delightful or disastrous, depending on how we look at this, is they informed us that they estimated we had saved Statoil approximately $10 billion a year of OpEx combined with additional yield from these wells. That's $10 billion to the good. I think we charged them $3 million for the work. We got to learn how to do a better job of that. Not good news on our value pricing, folks. There's another thought. Moving right along. You know, everybody talks about predictive maintenance, predictive things. You know, I wanted to just do, and forgive me, it's very simple, but I wanted to do this for a reason. Just show a really simple picture of what we're talking about when we talk about doing this sort of predictive, you know, work. We start with what they call a performance failure curve, and it's a very simple concept. The top, where it says smooth operation, is simply the normal operation of any element in a system. You actually, at some point, see a fall off in performance or a deviation from the norm, and eventually it fails. And the time between the first sign of trouble and the failure is the warning time. That's not a surprise. There's nothing magic there. The trick is, what you don't ever want is what happens at the end, because that's not a system. It's not rather a failure of just that component. It takes the whole system it's part of down with it. The key factor that you've got to remember, and this is the incredible value, that predictive window, the time between when you first see an issue and when the entire system crashes, is precious. Because from a financial point of view, what can often get lost is at the first sign of trouble, it may be as simple as replacing a bearing in a turbine on a jet, versus at the end of it having a catastrophic and destructive failure of that turbine, leading, in fact, to the jet no longer being serviceable. And what you've done is you've just turned a $1 million problem into a $300 million problem. This is, not to mention the risks involved. It is absolutely vital to maximize that predictive window to enable you to avoid these kinds of disasters. The financial implications of it across the board are very, very significant. There's a long list of places this has been executed. This is not new. From our own perspective, going back over 10 years, we've invested roughly $17 billion acquiring companies that do analytics such as Cognos, SPSS, Netezza, as well as another $8 billion in developing internal capabilities. This is about a $25 billion bet we made here. This work is finished. This is not new work. This is work we're done with. There are good examples. I'm not going to crawl through these. These are large numbers. I'll give you one that is public. We worked with the Boeing company back. They published the results in their own internal magazine, which is open for you to look at, in 2014, where they actually have tools they use to literally tighten the bolts in airplanes. You know, this keeps the wings attached. It's a rather important process. What they were finding was, even though they had scheduled maintenance of these tools, every once in a while, one of them would be significantly out of tolerance, where the torque with which it tightened the bolts was low. You literally could have to go into the field, dismantle the interior of an aircraft, and re-torque the bolts. This is unimaginably expensive. And so we worked with them closely to build a predictive system so that instead of scheduling the maintenance of their tools based on time, we scheduled it based on need by using sensors and IoT, and magically the problems went away. Incredibly valuable. Now, there is an example I'm going to show you. It's a video. It's relatively short. But it's a very valuable lesson, and I want to leave a little time at the end for a couple of questions. This is a company called Schaeffler. And this is actually a video involving their CEOs and their chief engineers. What they do is they build bearings. Bearings that literally are from a millimeter in scale to bearings I could walk through that are used on wind turbines. They have everything in between: automobiles, jet engines. So if there is a failure, it is catastrophic. What we did, working again in close alliance with them, is we used some of the most sophisticated analytic tools and cognitive tools to enable them to optimize the lifespan of this equipment and predict in advance, well in advance, when they would see a failure. So instead of having a catastrophic failure of a hyper-expensive piece of equipment, you could shut it down and do the repair before it became damaging. They actually, again, go all the way back to the front of their supply chain and follow it all the way through its use in major implementations. So it's extremely important that they have basically figured out how to capture the entire ecosystem. And it's a model that if you're going to develop a manufacturing center here that is literally 10x, as has been desired, really 10 years out in front, it requires that you start to use and really base that growing ecosystem around some of these very sophisticated methods. So without further delay, hopefully this will work.
We want to make a contribution in making the world a little smarter, a little cleaner, and a little safer. We deploy bearings in particular, from very small bearings with 1 millimeter to 2 millimeters diameter to the very large bearings that are used in wind turbines. In the automotive business, here we have the full spectrum from bearings within the chassis to complex transmissions up to e-axles and hybrid modules that are used in hybrid technology or in electric vehicles.
Industry 4.0 is not digitization or digitalization of mechanical industry, because this is already there. Industry 4.0 is getting the data, real-time information structure in this supply and manufacturing chain.
Our bearing of the future will be a digital-enabled sensor, in addition to the bearing standard functionalities, being part of the Internet of Things and being part of our value generation, which links bearings with more complex systems, with electronics, embedded software, as well as with additional services.
If we use IoT, if we combine this, if we use this data in a different way, we can be more flexible. So we can adapt faster, make decisions if something unforeseen happens, even in the cloud, even with cognitive systems.
We understand a lot more. We are able to build the models describing reality in the digital in a much more precise way, and allows us then to take actions on that in a way which was not known to up to now.
We created a so-called tooling machine 4.0 together with partners, and this machine has a lot of bearings where we installed sensors to measure torque, to measure temperature, measure speed. So this is important for our own efficiency, for our own improvement, flexibility. We can transfer this on a railway system. So we can check the bearing and the chassis behavior of a high-speed train. We can get measure when the situation gets critical for safety reasons.
We think highly about delivering customer value, and therefore we will embrace this opportunity and do it in a sustainable manner to the benefit of our customers. We are trying to embrace the whole idea of digitalization in a very holistic manner within the company by our Digital Agenda 2020 that we run systematically across the company. I believe we are complementary with IBM in that respect. We think that a true partnership between Schaeffler and IBM will guide us into the digital age and help us to shape the mobility for tomorrow.
if you think about the criticality of what they showed, they were trying mass transport systems, jet engines. You know, these guys basically build stuff on which our lives depend. And as a consequence of that, it was absolutely vital to get it right and keep it right. Now, the beauty of this system is it can be adapted to almost any situation. If you think about the diversity of things that can be done and done here, because of the unique situation you have, it's tremendous. In the top row, that large red engine, it's on ships. Why is that relevant? Well, you have one of the largest transshipment points. Actually, I believe it is the largest transshipment port in the Middle East. Maintenance. Being able to ensure that that engine works every day, every time, at peak efficiency. If fuel is one of the major costs of moving goods, you can have an impact. You have the ability here, because of all the digital records and because of what's going on with your deployment of blockchain, to track these ecosystems from end to end with absolutely secure control of the data, who owns it, who sees it, who can use it. The manufacturing that can grow here, because it's just nascent. You got Strata, you're doing some really amazing, very high-tech things, but you're just beginning. The jobs that it will create, by the way, and this is the good news, are extraordinarily high-skilled, high-paying jobs, because it's not somebody who's lifting the bumper and putting it on a vehicle. It's somebody who truly understands the workings of this end-to-end ecosystem and can leverage the sophisticated technologies involving AI, learning. All of these things basically are possible in many, many arenas. It's really a question of just picking your fights and making your bets. But I have seen, because I've come here for many years as part of both the World Economic Forum, working with Future Circles groups, I've seen this incredible rate of growth in the UAE, and I have absolutely no doubt you will put these capabilities to use faster than anyone around. And I believe that is going to be one of the keys to the future for this area. So thank you very much. I would open it up perhaps through my host here for some questions if we have time.
So we have 2 minutes. So, we can probably just take one question. So first person to put a hand up and who I see we can go for. Anybody have a question about Industry 4.0? Yeah, halfway up over there. Do we have a roving mic? Oh, there's one coming.
There we go.
Yeah. Oh no, further to the right. Yeah. Yeah.
Thanks, David. How are you doing? Etna Trainer is my name. Just a question, and very interesting to hear that you did some work in the oil industry, particularly with Statoil. I think here in this area we recently had a conference very much addressing these issues. And again, talking about the available data that's out there. Everybody has got used to gathering the data. They're getting really, really good at that. But unfortunately now, they don't know what to do with it, a lot of them. And we were hearing from some of the management consultants that probably only about 2% of the data that is gathered, particularly in the oil and gas industry, is actually being used. Obviously, what you've just done is a great example, but perhaps you might want to be sharing that with some of our colleagues in the region. But why is it so low?
You know, one of the challenges is people have been doing things for now in this area for upwards of 100 years almost. And it's very hard to overcome inertia. I mean, there's been an understanding that we have to digitize. But the interesting thing is the smarts, the intelligence, actually is a relatively recent thing that's come along. And so my suspicion is it's simply a time lag. But again, one of the advantages in this region is when you make up your mind to do something, it happens at warp speed. So what I'll do is I'll give you a card and connect you with people who did the work. This is eminently doable. If you have the data, it can be run. It's that simple. But beyond estimating that it's really just a question of there being massive inertia that you need to overcome, I don't really have a good answer as to why it hasn't been done. It can be done globally, no question at all.
Great. Well, I think that's a great question perhaps for GMIS in 2019. So yeah, we have all this data here. What do we do with it? Thank you very much, Dr. Bernie Meyerson.